Hi, welcome to the Practice 5 chapter test. We are going to start with question number 3. It says factor, and the hint is to take out the GCF first. So we look at each of the terms, and we take out the largest possible thing that can be divided out of each term. There are no numbers in common, but there are x's in common, and x squared is the highest amount of x in common. So it's like dividing that out, or undistributing, or however you want to think about it. So we'd have what, x to the fourth plus 14x squared plus 13. Multiply it back and make sure that it's really the right thing. So you're multiplying this times this, that would be the 6, right? This times this would make it 4, x to the fourth, and then this times this would be 13x squared. Notice those are going to disappear because of the magic ink that I'm using. So make sure when you actually take out the greatest common factor, multiply it back and make sure that it makes sense. Okay, and then we're going to factor it a second time. The x squared drops down. 2 sets of parentheses, put an x in each. Nope, that would be a lie. We're going to put an x squared in each. 13 is a prime number, so there's no choices. 13 and 1. The next one, take out the common factor. This time there's a number in common. 2 is definitely in common, but that's not the greatest. We're going to take out the largest factor, and that would be 4, and also an x. So everything gets divided by 4x. 8 divided by 4 is 2, so it would be 2x squared, 9x, and 5. This one here, the factoring, the second time is a little bit more difficult because we have to make sure we pay attention to the 2 in the front there. Okay, I'm going to put the 5 opposite of the 2. That makes 10, negative 10x, and then plus 1x would make the 9 in the middle, the negative 9 in the middle. And again, don't be afraid to check your work. Foil it back to make sure that it works. All right, here we're going to multiply. Another look at that. Oh, you have the answer key in front of you too, so we're okay. All right, we're going to make a polynomial function in standard form with the given zeros. So the 3 gets moved over. That means x minus 3. The negative 2 gets moved over, x plus 2. The 5 gets moved over, it's x minus 5. Then I do the trick of multiplying the two things together in the back first, and leaving the yellow one there by itself, and then multiplying that in. So here we go. You guys were pretty good at these. I'm going to extend the page here just a little bit more. And there we go. So y is equal to, leave this alone, x times x times the negative 5, just foiling here, 2 times the x, 2 times the negative 5. Those go together. So we get x squared. You borrow 5 from the aunt. You pay her back 2. You still owe her 3. Now we're going to do the multiplying of all the x times that and all the negative 3 times that. So here we go. X times each one of those would be x cubed minus 3x squared minus 10x. Negative 3 times each one would be negative 3x squared plus 9x plus 30. And now we collect our like terms. The x cubed has no partner, so it drops down. The x squareds, they're the same, so they're going to double up my negative 6x squared. Putting the x's together, I have negative 10 plus 9. You borrow 10 from the uncle, you pay him back 9, you still owe him $1. I don't need the 1 there, but you can put it, so you can write negative 1 or just minus x plus 30. All right, that matches up. Remember the Christmas clam, we talked about that. So remember you take the x times each one of these. There's the top part of the clamshell. And then you do the negative 3 times each one of those to make the second part. So the green made this green right here. And then the red made this red right there. And you collect your like terms. Okay. The next one is is just find the zeros of the function. Well, once something is factored, you just set each factor equal to 0. So we do x plus 9 is equal to 0, x minus 4 is equal to 0, and x plus 7 is equal to 0. This is easy to solve. We just subtract the 9 over, so we get x equals negative 9. We add the 4 over, and we subtract the 7 over. So there's my zeros of the function. Number 8. Did you notice I skipped 7? I went from 6 to 8. I didn't catch that until just now. Okay, we're going to solve by factoring. So we're going to factor, which means we're going to make this be two sets of parentheses, put in x in each. X squared, x squared. 7, or no, wrong problem. 45 would be 9 and 5. And the 9 has to be negative and the 5 has to be positive. Then we do zero product proper t. We set the individual factors equal to 0. We're going to add the 9 over, take the square root, x equals plus or minus 3. We're going to subtract the 5 over, take the square root, get x is equal to I plus or minus the square root. Whoops, I lost the plus or minus. Let me back up here. Plus or minus, take the negative out, I radical 5. So there's the 4 solutions. Remember, x to the 4th is going to yield us 4 solutions. All right, number 9, this is a two-parter. This is the one that's kind of the tough one. We identify what's being cubed. X is being cubed to make x cubed. And then 7 is being cubed to make 343. So now I'm going to put those into the factoring pattern, which I provided for you. So it's x minus 7, x squared plus 7x plus 49. That's how it factors. That's if I multiply this out with that Christmas clam, it would make the x cubed minus 343. We set each factor equal to 0 using the zero product proper t. So we got x minus 7 equals 0. That's the easy one. X is 7. There's one solution. Now we're going to come up with the other two solutions from this quadratic. This quadratic does not factor, so we're going to use the quadratic formula. And so we get x equals negative b, so it'll be negative 7 plus or minus the square root b squared minus 4ac. Now that's the discriminant, and to save time, if you do b squared minus 4ac, you should get negative 147, and 2 times a is just 2. Now, I'm going to, whoa, that moved, so I don't want that to move. So we're going to lock this in place. Lock in place. Okay, I'm going to pause this for a minute. All right, the announcements came on and stuff, so I paused it for a minute. And I'm going to minimize that. Here we go. So I'm going to grab here, bring this down, and then I pick up the red pen because remember I split this up as best I can. Negative comes out. 49 plus 49 plus 49 is 147. So 49 is the largest perfect square that comes out, and 3 times 49 makes the 147. So I get x equals negative 7 plus or minus 7I radical 3 over 2. And that's the other two solutions. At the bottom of the page, we have division. You can do long division or synthetic. I'm going to do synthetic division here. Remember, you change the sign, 3. And then you get 1, negative 7, 4, and 30. We drop the 1 down. We multiply, 3. We add, 4. We multiply, 12. Oh, it's negative 4, so it's negative 12. My bad. Add, negative 8. Multiply, negative 24. And the remainder is 6. So this one actually has a remainder to it. So remember, this is the remainder, this is the number, this is the x, this is the x squared. So it's 1x squared minus 4x minus 8. The remainder is a fraction. It's the part that remains out of the whole, like remaining pizza. One piece out of 8 would be 1/8 of the pizza, 1 out of 8. So a remainder is a fraction. And it's 6 over x minus 3. There we go. Okay, 11. Unless I skipped a number again. Okay, use synthetic division um, and the given factor to factor this completely. So this is getting us ready to start the solving process, but you have to factor before you can solve. So we're going to factor, that's my factor. I'm going to divide the factor out because that's what a factor does. It divides in. Switch the sign. And I'm going to pause again here. All right, the announcements keep coming on. So 1, -4, -9, and 36. Here we go. Drop the 1 down. Multiply. -3. Add. -7. Multiply. Add, which would be 12. Multiply. -36. Well, it makes sense that the remainder is 0 because I told you that it's a factor. That leaves the quadratic x squared minus 7x plus 12. This gets factored again because we're trying to put it into factored form to completely factor it. So 2 sets of parentheses, put an x in each. How about 3 and 4? 3 and 4 make 7, 2 negatives. So there's that part, plus the original factor, which was x plus 3. So y is equal to the original factor, x plus 3. The two new factors that I found is x um, minus 3 and x minus 4. So what I'm saying here, I'm going to go full screen here for a second. What I'm saying is, with the highlighter and yellow, saying that this is the factored form and this guy up here is the standard form. So I had a factor given to me and I had synthetically divided that factor out, leaving a quadratic, and then that quadratic factored again. So the only thing left to do would be to make it be equal to 0 and solve it. But it didn't say solve, it just said factor it. So it's a practicing of the factoring part. Okay, P over Q. The last number, oh, I'm still in the highlighter mode. The last number is the P, the first number is the Q. So we got plus or minus 1, plus or minus 2, plus or minus 4. Those are the factors of P over the factors of Q. Plus and minus 1 and plus and minus 5. Now we're going to divide. Let me do the magic pen here. Pen, magic, color, orange. We'll make it orange for Halloween. So I'm going to divide 1 into each one of the numbers on the top. So I'm going to do 1 into 1, 1 into 2, 1 into 4. Okay, when you get done doing that, then you're going to do 5. You're going to do 5 into each one. Divide 5 into each one, and that'll generate all of my likely guesses. So 1 divided by 1 is 1, so it's plus or minus 1. 1 into 2, plus or minus 2. 1 into 4, plus or minus 4. Now I'm going to get some fractions. 5 into 1, plus or minus 1/5. 5 into 2, plus or minus 2/5. And 5 into 4, plus or minus 4/5. So hopefully one of those would make this work. Okay, 13. How are we doing for time? Pretty good. 13, I gave you one of the factors and or one of the solutions, and you have to figure out how to factor it and then find the other solutions. Okay, so -2. -2 is one of the answers, so I'm going to synthetically divide by -2. And I'm going to go back to the blue pen. So -2, 1. Don't forget the 0 because there's no x squared. -10 and -12. Drop, multiply, add, multiply, add, multiply. Now, that basically reduces it down to a quadratic. So I have x squared minus 2x minus 6 from these numbers here. Set that equal to 0. Well, guess what? That quadratic does not factor, so I do the quadratic formula. So I get x equals, from this one here, negative b, which would be a double negative, 2, plus or minus the square root over 2a, which is 2. The b squared minus 4ac is the discriminant, and in this case, it should be 28. Let's go over that discriminant. It's negative 2 squared minus 4 times a, which is 1, times c, which is negative 6. So that squared is 4. And then all of this together is positive 24. So it makes 28. Okay, I pick up the red pen because I'm going to pull out the largest perfect square out of the 28. And that would be 4. So now I can reduce it down to 2 plus or minus 2 square root of 7 over 2. The 2's can all be divisible. So it's 1 plus or minus square root of 7. All right, moving right along. This one here, it's asking you to solve it, but you have a graphing calculator at your disposal. So you graph this on the calculator and look for one of the roots, one of the places where it crosses. And if you graph that properly, you're going to see that this crosses at negative, or no, not negative, but positive 4. So this problem turns into just like the last problem, but you get the solution of 4, right? So now I'm going to start over like where I was before. I'm going to synthetically divide by 4. So I get 4, 1, negative 4, 9, and negative 36. Drop, multiply, add, multiply, add, multiply. Okay, now I'm going to, what am I going to do? Oh, so that means that this is x squared plus 9 equals 0. That's the leftover quadratic. I found this x equals 4, which is the same as this 4 over here from the calculator by graphing it. So you type in the calculator, graph it, see where it crosses. And then I'm going to subtract the 9 over because I don't have to do the quadratic formula in this. I can just do simply the square root method. So I get x equals, the square root of 9 is 3, the square root of negative 9 has the I in it, and don't forget the plus minus. So there's the other two solutions. So x equals 4, right? I can't emphasize this enough. There's 3 solutions. X equals 4, I told you it came from the calculator. And then I get 3i, and then I have negative 3i. All right, that's the bottom of the page, so I'm going to go to the next one. Now this one here is x to the 4th power, so I have to have 4 solutions, and I'm going to graph this on the calculator. The calculator is going to tell me that x equals 6, it crosses at 6, and x is negative 3, it crosses at negative 3. Those are from the calculator. I'm going to synthetically divide twice now because I have 2 solutions and then be left with a quadratic. So 6, 1, negative 4, negative 16, 21, 18. This is going to have a remainder of 0, right? Because I'm telling you it's a solution from the calculator. 1, 6, 2, 12, negative 4, negative 24, negative 3, negative 18. Remainder 0. Now I start over again. So this is now, this is the number, right? This is x squared, this is x cubed. So I've reduced this down to a cubic. But I know the other solution is negative 3. So I'm going to do divide by negative 3. 1, 2, negative 4, negative 3. Drop, multiply, add, multiply, add, multiply, remainder 0. Okay, so now I have this quadratic to solve. The quadratic is x squared minus 1x, or just minus x, and then minus 1 equals 0. So the quadratic is right there. Okay, this does not factor, so I'm going to use the quadratic formula again. I get x equals negative b, so it would be 1, because it's a double negative, plus or minus square root. 2a is 2, and then the b squared minus 4ac, it's simple. There's nothing to simplify it. Actually, the discriminant just works out to 5. So you don't have to do any more simplifying there. And the last one. We're going to use the row 5. Row 5 is the one with the 5s in it. And remember, the x's are going to go down, the 2's are going to come up in power, and then you throw in the coefficients. And that's how you expand this cubic, or not cubic, but this quintic polynomial. Quintic, yeah, because it's the x to the 5th. So here we go. 1 x to the 5th plus 5 x to the 4th. Bring in a 2 to the 1st. Coefficient 10. Drop 3. 2. Bring it up. 2. Coefficient 10. X. Drop 2. Bring it up. 3. Coefficient 5. X. Drop 1. 2 to the 4th. Plus 1 and then 2 to the 5th. So does this meet all the criteria? Did I use all the, let me go to highlighter, yellow highlighter, 1, 5, 10, 10, 5, 1. I've used all the coefficients. Do the x's go down in power? 5, 4, 3, 2, 1, no x. Do the 2's come up in power? No 2, first, second, third, fourth, fifth. Now it's time to simplify, and so what you do is you go through each term one term at a time. So you simplify this. That's a little small. Make it a little bigger. Like that. There we go. So you got to simplify this. You got to simplify this guy. You got to simplify this guy. And this one. And this one. And that one. So it's like 1, 2, 3, 4, 5, 6 little baby problems. The first little baby problem is easy. X to the 5th plus 2 to the 1st is 2 times 5, 10. X to the 4th. 2 to the 2nd is 4. 4 times the 10 in the front would be 40. X to the 3rd. 2 to the 3rd power is 8 times the 10 in the front. 80 x squared. 2 to the 4th is 16 times the 5 in the front would be 80 again, x. And then 2 to the 5th. When I was 32 years old, I used to tell people I was 2 to the 5th. That was like 14 years ago. So here we go, 32. So this is the answer. I really want the simplified one. All right, well, it's been a pleasure. 23 minutes, just under 25. And I skipped the first two just because you got to graph it on the calculator, and we did a whole bunch of that in class, and I think you'll be okay. All right, hopefully this is helpful. Bye-bye, see ya.